Guys, Miss Torelli here, and today we're going to continue our conversation of speciation. We're going to be talking about two different types of speciation and how the second one is different from artificial selection because it can be easy to confuse them. So that's what we're going to be looking at today. In order to start, let's do a quick review of yesterday. What are the 3 steps of speciation? The 3 steps of speciation are isolation, adaptation, and differentiation. And the 2 different types of speciation that we're going to be talking about today really focus on this first step right here. So the 2 types come from differences in isolation, so differences in how that one population becomes isolated into 2 totally different groups. How that happens is going to determine what type of speciation we're talking about. So again, we're really going to be focusing on this isolation piece today. So there's 2 different types of speciation. The first type is sympatric. The second type is allopatric. So sympatric, sim means same. It even kind of sounds like the word same. And patric is similar to the word patriot. So it literally means country. So sympatric means the same country or the same place. So sympatric isolation happens when a new species develops, when speciation happens in the same place. Allopatric, as you might have guessed, is the opposite. Allo means different. So allopatric speciation is when a new species develops, when speciation happens in 2 totally different places. So there's 2 types of sympatric speciation. There's behavioral and temporal. There's only 1 type of allopatric speciation, and that's geographic. And that's what we're going to be talking about first. So allopatric is easy to remember because it's species developing in 2 totally different places. And if the species develops in 2 totally different places, you can guess that some kind of geographic event has to have happened to separate them. So what are the 2 types of speciation? Great, the 2 types of speciation are again allopatric and sympatric speciation. So allopatric speciation is when 2 populations are separated by some kind of boundary. There's a lot of different examples of this. It could be a volcano, it could be an earthquake, it could be a hurricane, it could be a mountain, it could be a flood, it could be a glacier, it could be a river, it could be a desert. There's a lot of different examples of geographic barriers that might occur that would separate one species into 2 groups. One example of that is this squirrel. Now, these 2 squirrels have a recent common ancestor that used to live in this area before it became the Grand Canyon. When the Grand Canyon was formed, when that crack started to separate, it separated this one group of squirrels into 2 different groups. Now, as it happens, the environment on one side of the Grand Canyon is pretty different from the other side of the Grand Canyon. So as those 2 species evolved on both sides of the Grand Canyon, they became very different, which is how we ended up with the Kaibab squirrel and the Albert squirrel. If you put these 2 squirrels together today, they would no longer be able to reproduce fertile offspring. So they'd no longer be able to have babies that could have babies of their own, because they have become so different that they've actually evolved into 2 different species. They're still squirrels, but they're 2 different species of squirrel. So what does allopatric speciation mean? Allopatric speciation means different place, and it's when 2 different species evolve from one species that has been separated by a geographic boundary, some kind of geography separating them. All right, so then you have sympatric speciation or sympatric isolation. And that happens in two different ways. The first is behavioral. And that's when differences in behavior of two populations prevent them from interacting very much. Here's an example. There was one type of fly that used to inhabit both apples and hawthorns. Now, apples and hawthorns are actually two totally different types of fruit that are in two totally different types of trees that you'll find in two totally different types of places. So you're not going to find these in the same spot. As it happens, some of these flies preferred eating apples, and some of these flies preferred eating hawthorns. Now, if you are a fly living in an apple tree, you don't need to ever go over to a hawthorn tree if you don't like to eat hawthorns. If you're a fly that prefers hawthorns, you don't ever need to go over to an apple tree if you don't like apples. So the flies that liked eating apples and the flies that liked eating hawthorns never really had a reason to hang out or meet or interact. So after many, many generations, those flies actually evolved into two totally different species of fly. And because fly lifespans are so short, we've actually been able to see this happen. So again, the flies that were living in the apple trees only mated with other flies that liked eating apples. The flies that liked eating hawthorns only mated with other flies that liked eating hawthorns, because those are the only flies that they ran into. Those are the only other flies that they interacted with. So that would be a great example of behavioral isolation, behavioral sympatric isolation. Here are some other examples. You could have mating rituals, mating preferences, or mating calls. Mating calls is actually a pretty common one. Birds tend to prefer very specific types of calls. They only like to mate with other birds that can do those very specific types of calls. So naturally, because of mutations in the population, in the DNA, some birds are going to be able to do different calls than others. Maybe one will be able to do a cool, like, high-pitched sound. Maybe one will be able to do a cool trill. Whatever awesome bird song they come up with will attract a certain type of mate. And pretty soon, only birds that can do that type of song will be mating with each other. And ones that can't won't be mating with that group. So that's another really good example of behavioral isolation. So which one of these would not be an example of behavioral sympatric speciation? So sympatric isolation takes another form. This is the second type. This is temporal isolation. Temporal is just a fancy word for time. When I say temporal isolation, it's just isolation that has to do with time. And that's when groups prefer mating at different times. So either a different time of day or a different time of year. Maybe, for example, cats might have better eyesight during the night than during the day. Cats that have a certain mutation that have especially good eyesight at night might prefer mating at night. Cats that have better eyesight during the day might prefer mating during the day. Maybe, they want to mate when it feels safe. So they want to mate when their vision's better. So that would create two different groups. The ones that had the genetic mutation to have better eyesight at night might prefer mating at night. So nocturnal versus diurnal, that just means at night versus during the day. That's all that means. So you might see those preferences occur in temporal isolation. Then you have seasonal mating preferences. Maybe cats that have warmer fur might prefer mating when it's cooler. Cats that have cooler fur might prefer mating when it's warmer. So during the winter, during the fall, during the spring, those mating preferences are just called temporal isolation. They would separate that one group of cats into two different groups based on their mating preferences. Here's an example. These two frogs used to be the same species. Some of the frogs preferred mating earlier in the season. Some of the frogs preferred mating later in the season. Because of those differences in preferences, we ended up with two different species of frogs. the wood frogs that prefer mating earlier and the leopard frogs that prefer mating later. What are the two different types of sympatric speciation? Great, so again, the two types of sympatric speciation are behavioral and temporal. All right, so it is pretty easy to get sympatric speciation confused with artificial selection. Here's how you tell the difference between artificial selection and sympatric speciation. In sympatric speciation, the animal is choosing what it wants to do. In artificial selection, the person is choosing for the animal. So if the animal is choosing its own mate based on what time of year it likes to mate, or based on the type of bird call it can make, or based on where it likes to hang out, that's sympatric speciation. That's the animal choosing for itself. If the person is choosing, that would be artificial selection. So if the person is deciding what kind of mate the animal should have and picking for it, that's going to be called artificial selection. And you all know a really good example of human beings picking mates for animals. What's one example you can think of? So I hope some of you came up with dogs. Dogs are the classic example of artificial selection, because what we did is we took wolves and we selected certain qualities that we liked. So one trait that varies among wolves is their pacifism. That's like how nice they are, their sociability, their ability to interpret human gestures, so whether or not they can easily follow human commands. And we only mated the ones that had the qualities that we liked. So we picked the ones that were the nicest, that were the cutest, that were the friendliest, that could interpret our commands, that would follow our commands well, and we only mated those together. Until pretty soon, over many generations, we ended up with the modern dog. And the modern dog has taken on many permutations as well. So we've taken dogs and we've bred them to do very specific jobs and to look all kinds of different ways. And we've done that based on the traits we wanted. So if we wanted a really strong dog, we might breed a husky. If we wanted a dog to hunt like mice, we might breed a beagle. And that's how we ended up with so many different types of dogs, like this weird-looking Lhasa Apso, this adorable beagle, or this miniature Pomeranian. That was all done through artificial selection or human selection. So that's all we're going to be talking about today. For the rest of class, you're going to be looking at a brief video and filling out the questions on your sheet. Thanks for staying with me, and good luck.